Hello, good day to each and everyone. I decided to record this video so that you will have some learning resources as you go along with your review for your topics for your Earth science. So for this video, we are going to talk about the different types of rocks along with the rock cycle. So before we start our discussion, let's have first our introductory video. In three, two, one, go. So for today's video, we are going to talk about the different types of rocks. And for this discussion, we will also try to integrate the process that are happening in the rock cycle and how each type of rock can be transformed from one type of rock to another. So without further ado, let us describe first what is our learning objective for this lesson. So, first, we are going to classify rocks according to igneous, sedimentary, and metamorphic rocks. Next is we will be identifying common rock-forming minerals using their physical and chemical properties. And next, we will try to explain the importance of rocks in our daily life by citing some of its uses. So, without further ado, let us now begin with our discussion. First is, what is a rock? So, one of the things that we will be integrating as our infused values will be being grateful on the presence of natural resources and being a responsible individual. And we also integrate in this lesson the UN SDGs number 12 and number 15, which is the responsible consumption and production and life on land. So let us go back to the question that we had a while ago. What is a rock? So when you speak of rock, rock is, of course, um, we can see them everywhere, right? And the main idea of this discussion is that Earth's materials include rocks and minerals, and that they exhibit characteristic features and have economic value. And Earth's rocks undergo different transformations depending on these situations. So we will be discovering them for this lesson. So again, let us go back again to the question, what is a rock? So when you speak of rocks, that is, they are of course naturally occurring aggregate of minerals. So we can say that they are somewhat the building blocks of our minerals. And of course, on certain non-mineral materials such as fossils and glass. You might have noticed in some rocks where you can find some fossils of the remains of some plants and animals. Well, of course, they are just actually natural. And later on, we will be describing what are these types of rocks. No? So, they are natural building blocks of our Earth's lithosphere. And furthermore, furthermore, when we study about rocks, we call actually this field as the petrology, which is technically a branch of geology that deals with the origin, composition, structure, and as well as the classification of rocks. So, rocks are shaping the earth are actually very useful because they actually serve as somewhat a record keeping of how the evolution of plants and other organisms that have lived throughout the ages. And in fact, um, many of the world's fossil remains are found on rocks. And eventually, these fossilized remains of these plants and animals have become an available source of data or a clue of what was life way back then. And it also holds clues to what the climate had been like. And at the same time, what are the events that happened that led to the formation of crust, or let's just say what are the geologic events that led to the shaping of our Earth's lithosphere. So that's why rocks are a very important source of clues and information about how our planet Earth behaves in our geosphere. So technically, we describe rocks into three types. So we already discussed them when we were still in our elementary years, right? Wherein the common types of rocks were as follows. We have number one, we have the igneous rock. Then second one is that we have the sedimentary rocks, and of course, third one is the metamorphic rocks. Now let's describe them in detail one by one. So, when we speak of igneous rocks, they are formed from hardening and a crystallization of magma, or shall we say the molten material that originates deep within the earth. So that is what igneous rocks is all about. So that would mean that they come from the molten materials from underneath the earth's crust, which eventually cooled down for some period of time and solidified to become a rock. So ignis means fire, so that's what the etymology of the word igneous rocks came from. So that's what igneous rocks is all about. So now let's further classify igneous rock according to the location where they are formed. So according to where they are formed, so they can be classified as number one, letter A, that would mean extrusive or volcanic rock. So when you say extrusive, that means from the prefix X, that means it's outside. So that means that these are rocks that are formed when magma makes its way to the Earth's surface as lava and then cools down. So take note that when magma reaches the surface, we call it as lava. And as this lava cools down and solidifies, it crystallizes and eventually this forms igneous rock. But this crystallization, of course, is very small because, sorry, this crystallization is very small because, of course, the cooling is very fast. So that means that we can actually deduce an idea from that statement itself that if the cooling happened very slow, then we can think that the crystallization or the crystal structure of an igneous rock is usually large. But if the cooling happens very fast, the crystallizations are usually very small. So that's what extrusive or volcanic rock is all about. So we have several examples, no? So depending on the size and shape of its mineral crystals, so we have coarse-grained, porphyritic, fine-grained. We also have no crystals at all, like for example this one and the picture here. So that's what extrusive igneous rock is all about. Now, let's also talk about the intrusive or plutonic. So when you say intrusive from the word in, that means that these are rocks that solidified from beneath the Earth's interior. So it cools slowly beneath the Earth's surface and are created by magma because, of course, the molten materials that are still beneath the Earth's surface, we call them as magma. And since usually these kinds of rocks cool very slowly, usually these rocks contain very large crystals, or shall we say coarse grain, because they undergo a slow cooling process. So there, as you can see here, usually these rocks are coarse grain. So igneous rocks are also classified based on number one, composition. So based on the chemical makeup on the parent magma, or dark and light colored materials. So depending on the chemical makeup, igneous rocks may appear as dark and light colored, or it could be like, for example, for felsic igneous rocks, from the word felsic, this means it's light in color, and usually these rocks have high silicon and aluminum content, like for example granite and rhyolite, which are composed of feldspar and quartz. So if you are going to look for um, minerals like feldspar and quartz, then one type of rock that you should look into is, of course, granite and rhyolite. So we also have another type of rock according to composition. We call it as the mafic, which means this is dark in color. Wow. Dark in color, and at the same time it is made up of magnesium and iron. So that's what the classification of igneous rocks according to the chemical composition. Now, here there is really a very distinct way of identifying according to the composition, because usually the mafic rocks are light colored, while the felsic rocks, oh sorry, did I, yeah, the mafic rocks are usually light colored, and the felsic rocks are usually dark colored. So as you can see there, actually, an example, we have gabbro and basalt for mafic, and felsic rocks, granite and rhyolite, as I described a while ago. By the way, we somewhat I interchanged the description there. When you say felsic, that means it's light in color, and mafic, that is dark in color. As you can see here, mafic is darker than felsic. So sorry for that. Now let us move on to another classification, which is according to texture. So texture is of course how smooth the surface of the rock is. So we have here, of course, the texture of a certain igneous rock is affected by the arrangement of the interlocking crystals. And we have the aphanitic texture, we have the phaneritic texture, and we have the porphyritic texture. So what's the difference of the three? So when you say aphanitic texture, that means it's the crystallization is very fine. It's so small that you can hardly notice the crystallization in the surface. Then we have the phaneritic there. The crystallizations are very visible, as you can see from the picture here. And we have the porphyritic, somewhat the intermediary between the aphanitic and the phaneritic texture. So that's how different these igneous rocks according to texture. So let's move on to the another classification. So as you can see here, also glassy texture can be included here, like for example obsidian. Now usually the obsidian rocks before, since they have a very glassy texture, usually during the old stone age, the obsidian rocks are usually used as rocks for creating weapons. So that's why obsidian is very much popular during the ancient um, period. And we also have the pyroclastic igneous texture. Shall we say pyroclastic? That means also fragmental. So that's another classification according to texture. So as you can see, a while ago we just mentioned the classifications of igneous rocks from coarse grained and fine grained. Then we have the glassy texture there, the feldspar, and of course this rock here. So those are some examples of igneous rocks. So let us move on to another example of type of rock, which we call as the sedimentary rocks. So when we say sedimentary rock, it comes from the word sediments. So it provides information about the surface conditions that existed in the Earth's past. So these are usually the types of rocks that are usually associated with fossilized plants and animals, because usually this is where you can see the fossilized um, organisms and these types of rocks. Okay, so these are particles of sand, shells, pebbles, and other fragments of materials, which we call sediments, that accumulate layers and over long period of time to harden the rocks. So technically, these are sediments that eventually accumulated, that compacted and glued together for a certain period of time, not just a certain period of time, but for millions of years, thousands of years, in order to solidify and harden into a sedimentary rock. So that's sedimentary rocks for you. Now, just like igneous rocks, we can also classify sedimentary rocks. Now, to further um, define sedimentary rocks, these are the reasons why sedimentary rocks are formed. We have this so-called process which we call as the compaction. Due to the increase of pressure of layered sediments, it bind together to form the sedimentary rocks. Later on, I'm going to show you a diagram and how sedimentary rocks are formed in the rock cycle. So we have sedimentary rock types. We have clastic. That means they are formed from the breakdown material of other rocks that are eroded. Okay, and an example for this is they have the conglomerate, breccia, red sandstone, shale, and gray sandstone. So when you say clastic, that means they are from the break down materials from the other rocks that eventually eroded, and they have been accumulated for many years to form sedimentary rocks. Then we also have what you call as non-clastic. So these are chemically heat causes the mineral rich water to evaporate and leaves the material behind. So usually the process of heating causes this mineral rich water to evaporate and leaves the material behind. So as you can see here, a good example for this is the halite, or what we commonly know as the rock salt. So that's a good example that we can think of for non-plastic rocks. Another um, classification is of course the organic, which is of course the accumulation of animal debris. So that would mean that um, we can also form rocks from organic materials like decayed plants or animal debris. So, like for example, the limestones, limestone chalk, the shirt, which is a sedimentary rock composed of microscopic quartz crystals. There. So, we can also classify them into particle size. Like for example, letter A, coarse, medium, fine, and very fine. So, for example, gravel is a conglomerate. Okay, breccia, sandstone, siltstone, and shale. Okay, oops, sorry. Now, in chemical composition, like for example, for calcite, usually a good example for this is chalk and limestone, or uh, which is composed of what you call as the calcium carbonate. Halite, which is the rock salt, which we of course know as a chemical formula of NaCl, and of course gypsum, like for example rock gypsum, rock board, cement, plaster of Paris, and calcium sulfate. Okay, so let's move on to another example. Let's go now to metamorphic rocks. So for metamorphic rocks, they are formed from pre-existing rocks. They look at the keyword there, from pre-existing rocks, meaning to say they have undergone metamorphism, which is the transformation of one rock type into another. What are the types of metamorphism? So we have the regional metamorphism, which is of course due to the changes in pressure and temperature over large region of the crust. Now, we also have the contact metamorphism, which is mainly by heat due to contact with magma. So what is a good example of regional metamorphism? So if you remember your lesson in plate tectonics, we have a concept there of convergence of plates, which we call, of course, as the convergent boundaries, right? Now, during the convergence of boundaries, we have so-called as the collision of two plates. It could be a continental plates, continental oceanic plates, or from oceanic to oceanic plates. And as these plates they come into contact with one another, we also experiences what you call as regional metamorphism, where rocks are continuously being experienced, or shall we say, rocks continuously experience great heat and pressure, and as a result, these rocks metamorph and eventually um, transform into metamorphic rocks. Okay, so that's what regional and contact metamorphism is all about. Okay, so for reference, when you say contact, it only involves smaller area, and for larger area, we call it as the regional metamorphism. Okay, so let's move on. Like, what are the common metamorphic rocks? So, for example, if the parent rock is a granite, the metamorphic rock usually is gneiss. Now, if the parent rock is shale from the sedimentary rock, then the metamorphic rock for that is slate. And of course, if the parent rock is sandstone, which is of course a type of a sedimentary rock, usually when these sandstone undergoes metamorphism, it can be converted into a quartzite. So that's a good example for metamorphic rocks. Or it could be limestone. When it undergoes recrystallization, it becomes a marble. Okay, and we also have different types of metamorphic rocks. When you say foliated, these are grains that are arranged in planes or bands. Like for example, slates, sheets, schists, and gneiss. And for non-foliated rocks, these are grains that are not arranged and usually contain only one mineral, like for example, marble and quartzite. Okay. Now, metamorphic rocks usually are formed due to extreme pressure, like for example, earthquake and heat from a volcanic eruption, like for example, gneiss, right? And marble and slate. And what are the common uses of metamorphic rocks? So, like for example, for slate, they are usually used for roof, floor tiles, chalkboards, and for gneiss, they are used for flooring, ornamental stones, and gravestones. So, marble, these are building stones, of course, monuments and statues. As you can, you have actually seen many of these types of metamorphic rocks already based on their uses. So, to summarize everything, um, here's a chart that I usually use to practice, for you to practice identifying some of these um, rocks that are listed here on the left side, and summarize them into what type of um, rocks. So we can classify them as igneous, sedimentary, or metamorphic. So just to run everything shortly, so let's classify them right now. So these are good examples of igneous, sedimentary, and metamorphic rocks. Now, I mentioned a while ago that um, we will also include here the discussion on the rock cycle. So let's first ask this question: how does classifying rock into three types enable scientists to know more about Earth? And we answered this a while ago, like the rocks contain clues about what the Earth was like in the past. So let us further identify how do each of these rocks interact with one another. So we can simply describe their interaction through this map we call as the rock cycle, which is of course the process of rocks that go through which they form or change into new rocks, and it has no beginning or end and is always continuous because of course this is a cycle, and this makes it a cycle of nature. Now, I can show you this rock cycle in this way here. Now, a basic question here is, does every rock go through complete rock cycle? Now, if you're going to look carefully at this diagram, not all rocks actually undergo complete rock cycle. Okay? Others can just jump into one process to another and then be converted into another um, type of rock. So I will show you a more clear picture later on. Now, if you want to understand rock cycle in a nutshell, it's like this. Allow me to fast forward this one. Here is the picture that I would like to show you. Like for example, I would like to start here with magma. Let's just say that this is our starting point, but technically the rock cycle has no starting point. Now, let's just say if the magma from the Earth's interior solidified, it becomes an igneous rock. Okay, that is a very common knowledge because any molten material from the Earth's interior solidifies becomes an igneous rock. Now, as this igneous rock undergoes weathering and erosion through uplift, as you can see here, there is a process there through uplifting. They are deposited in a form of sediments. Okay, let you follow. So they are deposited in a form of sediments, and take note, as these sediments undergo deposition, burial, compaction, and lastly sedimentation, they are now formed into sedimentary rock. Or it could be, like for example, if these sediments also have undergone erosion, okay, it goes back to the process and then eventually it is converted into a sedimentary rock. Okay? Take note of this. Okay? Now, it could be also that from solidification, this igneous rock, due to either contact metamorphism or regional metamorphism, it undergoes heat or pressure, and it is also converted into a metamorphic rock, and vice versa. So you can use this chart actually to understand how each of the rock types are actually converted from one type of rock to another, depending on the situations where rocks experience this um, different factors that affects their formation. Okay, so that's what rock cycle is all about. Now, a very important question here is, of course, I don't need to answer this, but I would like to leave this question for you as we end this discussion. Do rocks have value to people? Um, Cite examples. Or how can we help the DNR preserve and use the rock resources properly? Well, um, there have been lots of activities pertaining to the uses of rocks and how we use rocks commercially in, of course, the industrialization of our communities and our society. So how can we help the DNR preserve and use the rock resources properly? So our takeaway for this lesson would be studying rocks help us to piece together the story of how the geosphere, the Earth's rocky outer layer, has been shaped and changed over time. And the underlying all the Earth's land and water, rocks provide a foundation that supports the living world, gives clues about past life forms, and provides us with many materials that we use in our everyday lives. And we will end our discussion for rocks on this slide. So I hope that you have learned something out from our discussion for this video. So keep posted and updated. I might also post also another discussion in a separate video on types of minerals. Once again, thank you so much for listening. God bless you all. See you next time.